Okay, so this is the block diagram for the Nova Series lasers with the version 8 TL timer board in them. This does not reflect the change of the newer machines since around January of 2020 having the chiller connected directly to the laser for the power. But we'll go over that in a minute. This is some basic overview of how the AC power is what we're going to focus on right now. But we'll cover some other things in it too. Now this is your AC power block. This is where your main power input is. This is where that quarter turn quick lock connector goes. And there's a circuit breaker you'll notice here, not a fuse anymore. Since about 2019 there's been circuit breakers there. Now they're not in the right spot here. They just renamed that from fuse to breaker. The breaker is actually on that main power termination rail that's in the electronics bay, but you'll see it. So your main power comes in. First and foremost, you need to make sure that your supply power is okay, a nice clean 110 volt 20 amp dedicated supply. And once you've verified that, if you're having power issues, look at your connector, look at that twist lock, check the pins inside. It'll be hard to look at them, but make sure there's no evidence of arcing or melting or deformation of the connector due to heat or thermal insult or something like that. These may be soldered on to the connection into the wiring harness of the laser. They may have push terminals on there. Check the connections on the back side, on the inside of the frame. Where all of these connections are. Now your main power input, your air pump socket, and your exhaust fan socket will all be right there together. I know these have push-on terminals. It wouldn't hurt to check those while you're at it. Just check all the terminations. Look inside the socket here on the main power input at the terminals as well, and the plastics inside. Make sure that it looks okay. Just visually inspect that wiring, all that AC stuff right in the rear of the machine there. So here's how it works. Once your power goes in, it goes through actually to the terminal block through the breaker, and then it's all distributed from here, from this section. Now we're dealing with 110. This is a Chinese document. It says 220 here, but just know that this is 110 for all the USA versions. So the main power is distributed through here. They go through some filters. There's filter 1, filter 2. So here's the way this works. When you turn on the main power, I'm sorry, when you plug it in, you'll get power energized through the breaker all the way to this terminal block, and it'll come all the way around to these two EMI filters. That's those silver boxes that are in the electronics bay near the wire rail. Now this is coming in two ways. There's two separate power 110 powers going to the rest of the workings of the laser. Through filter 1, you go through the emergency stop. This is the important one that we're looking at if you're getting a no power issue right now and your machine won't come on. So it'll go through this EMI filter and then to the emergency stop, and that emergency stop is a double pole, single throw. So it will kill, it will interrupt the line as well as the neutral. Now, if the emergency stop is correct and you have continuity here, if it's in the operating position, that power will go to the main power switch. Now, from the main power switch, that powers the contactor. I'm sorry, the contactor's on another one. The main power switch powers all of the rest of the power supplies, the low voltage stuff. It powers the 24 volt power supply, the 36 volt power supply, and some other things in there, contactors and such, relays. So then you have your laser power switch. Now what this does, it energizes this big contactor in there. That's that loud thunk you hear when you turn that laser power switch on and off. And that goes to the laser power supply only. It has its separate own dedicated AC circuit going through this separate filter, so it's isolated from the workings of the machine so you don't get noise on that line. Now on the ones with the chiller, your chiller is also connected to this circuit. So if you're looking for a no power issue, the main power switch can go bad. If your machine turns on but you can't fire the laser and or you don't have chiller power, it's likely this laser power switch, because that carries both on the ones where the chiller is in. So the points that you need to check is all the terminations. Make sure that the wires are tight. Give them a little pull. Make sure you unplug the machine before you go working in there and looking at things. You want to unplug it and ensure that the system is not energized. So check your cords, check your terminations, come over here, check your screw terminations. Just give these wires a glance. Then they'll go into some cable management and they'll go away. They'll be hard to trace after that. Over at your EMI filters, check those connections and make sure your emergency stop is functioning. If you're still not getting power, it's best, if you are confident that you can use a digital voltmeter, you should plug the machine back in and do a few spot checks to make sure that you're getting 110 into the machine. You can check it at the connector on the back side or on the front side, or you can just go to these screw terminals here, and they're labeled and they'll tell you which ones they are, and you can check for power here. If you get it here, you know that your power cord and all that stuff is okay. So then check it on this side, and if you get it here, you know that you're good. And then you can check it at the filters. You can check for AC power here on L1 and N1. And if you have it here, you can check it here. If you don't get it there, then you know that this filter's bad. Then check it at both sides. You just have to go through with your meter and hit these test points and see if you're getting 110. Check right here at the main power switch. Are you getting 110 right here? When the power switch is on, do you get 110 right here? If you don't, then that power switch is bad. Same for the laser power switch. And you can also do this diagnostics. Instead of looking for 110, it's a little more involved, but you can leave the system completely de-energized and do continuity checks here instead, and that's a lot safer. If you have a good understanding of how to work a meter, then I would suggest you try checking continuity at these places instead of checking for live power. But that's totally up to your skill and confidence level. If you have any worries about that, you may want to get someone in here to pop a look that is familiar with electricity. So anyway, just to recap, the main power goes in from the plug into the jack, through the breaker, through these two filters. One branch powers the control and the rest of the laser. The other branch powers just the laser power supply and the chiller, if is that model. So for the chiller and the laser power supply to work, both of these switches need to be on. The emergency stop needs to be good, and your breaker needs to be good. So those are the things that I would check first. And then you can report back what you find if you're still having issues, and we'll dig a little deeper. Anyway, that's a basic overview of the AC power on a Nova Series machine. Thanks.